Hello and welcome back to another episode from Spiral Physics Education. We're going to be looking at efficiency and Sankey diagrams in more detail this time. We're going to be looking at exam style questions in particular, which means it's a grade booster episode. We're going to be looking at different difficulties, so we're going to look at grades 4 to 6. We're going to be looking at some questions 6 to 7, and finally a grade 8 to 9, the most difficult of the questions. So you're going to need to know about stores and transfers, and you're going to need to know the principle of conservation of energy, about calculating efficiency, and also about Sankey diagrams. Check out the channel if you're not sure about how to do any of those. So let's have a read of a grade 4 to 6 exam question. So we're looking at how 2030 joules of 7,250 joules of electrical energy can be wasted. So we've got to think about how it's going to be wasted, it's not useful. And for a fan, that's going to be something to do with thermal energy, about dissipated energy, and about mentioning that it goes to the surroundings. So if I put something together like that, I'm pretty sure that I'm going to be covering all the points there for that 1 mark. So now we have part B, which is calculate the efficiency. So we need the efficiency equation, which we could write in as a percentage equation as well. So if we then try to identify all the numbers on there, we are given the total amount of energy. That's the 7,250 joules of electrical energy. If we look at for useful, we're not told the useful. And if we think about the wasted, we're told that the wasted is 2,030 joules. So the first thing that we can do is that we need to do is calculate that useful energy. So remember about the principle of conservation of energy? The total amount of energy is always the useful energy plus the wasted energy. So we can rearrange that to calculate the useful. Useful is total minus wasted energy. And now we can substitute those numbers in. So we've got useful is equal to 7,250 minus the 2,030, and that gives us 5,270 joules, just about. Now we can use the efficiency equation, so we can write that out again, just to remind ourselves. Not going to do it as a percentage form for the moment. And now we've got useful over total, that's the 5,220 over 7,250, and that gives us 0.72 or 72%. So let's have another grade 4 to 6 exam question. So we're looking at why efficiency is increased by the addition of oil to a bike, and it's worth 2 marks, so we can't just say one thing. So the addition of oil is going to first of all be a lubricant, and that lubricant is going to reduce friction, and reducing friction is going to reduce the amount of thermal energy that's transferred or dissipated to the surroundings. So that means we've got 3 points there and 2 marks, so I'm pretty confident that I've got those 2 marks. So let's have a look at another question, and this one about materials that a builder is using. And he's going to be building a wall from 4 different choices of bricks, so it's only worth 1 mark, so multiple choice. So we look at thermal conductivity, we've got high and low, and we look at brick width, we've got 10 or 15 centimeters. So we need to have a look at what thermal conductivity means and whether a thick brick or a thin brick is best. And from that we can get our 1 mark. So let's think about what thermal conductivity means. The higher it is, the better it will conduct and transfer thermal energy, and that's a bad thing. So we don't want it to be high. So we want it to be low, and we want it to be as thick as possible. So the builder should really choose D. That would be the best possible brick for this house. But of course, it might be expensive. Okay, part B then. So part B is another way in which the builder could reduce the rate at which the house cools. So we're thinking that about, well, some of the way of insulating the wall or improving the insulation of the wall. And if you know about houses, they've got a cavity, so we could add a layer of insulation to the wall cavity. That would be one possible way of getting our 1 mark there. So part 3, we're looking at wasted energy using this Sankey diagram. So this Sankey diagram, it's got electrical energy going in. We've got 13.5 kilojoules of useful energy coming out, and we've got some wasted energy, and we're going to try and calculate that wasted energy. Total equals useful plus wasted. In terms of energy, total is 22.5, useful is 13.5. Rearrange it for the wasted equals, and that is 9, and we've got to remember the units. We've got 9 kilojoules for our 1 mark. So grade 6 to 7 question. A lot to read there, just pause the video to make sense of it. They're getting quite complicated now. And here we've got a diagram of an air blower turning blades with an ammeter and a voltmeter. So we're going to need to use an equation. So the equation is useful energy over total energy. We've got to try and identify all the numbers in here. So this is for the blower. So the useful energy output, rearranging this, is going to equal the efficiency times the total energy. And we're going to have efficiency of 0.6. Remember, that's not percentage, it's 0.6. And that's 30, but remember it's 30 kilojoules, so we've got to remember to multiply that by 1,000. And that equals 18,000 joules. So that's one part of this for our 4 marks. So now for the turbine. Well, the turbine has an efficiency in terms of percentage of 12%, which is 0.12. I'm just going to stay away from percentage in a moment, so I'm going to use 0.12 for my efficiency. And we can say that the total input is going to equal that 18,000 joules. I've already calculated it. So the efficiency is going to be the useful energy output over the total input energy. Quite a wordy equation. Remember, looking for useful, so you're going to rearrange this. Useful equals the efficiency times total, so I'm just shortening my equation there. And that's going to equal 0.12 times 18,000 joules, and that means that the useful energy output, which is the question, just do a quick calculation of that. (2,160 joules). So if I just change the colour of the pen to look at where we're going to get marks for that, I'm going to get 1 for writing that equation. We're also going to get 1 for calculating 18,000. We're going to get 1 for doing some sort of calculation down here, and we'll also get 1 with the units down there. So part B is about increasing the efficiency of the turbine. So the most obvious thing is, because there's moving parts, we could add lubricant which would actually reduce friction on the moving parts. And the second part is about the blades. So one of the things that we could do is increase the number of blades. That would increase the area of the blades and increase the efficiency, perhaps. And we could also perhaps change the angle that the blades make with the wind, and that could increase, possibly increase, the efficiency. So the hardest question of the lot, a grade 8 to 9. Remember to pause the video so that you can take in all the information that's being provided, and then when a question comes up, pause the video again, and then we will go through it step by step. Helps to have the diagram as well. So we're going to start off again by using the efficiency equation. So this is of the heater. So the efficiency of the heater is the useful energy output of the total energy input. And that's going to be the energy from the wind turbine to the heater. So we're just dealing with the heat for the moment. That's why I put an H there. So we can look at the total energy. I'm just going to use total for the moment to make it more useful. Is useful over the efficiency of the heater. And looking at the question, the useful for the heater is, in that question, we're looking at 0.68 megajoules. I'm going to leave everything in megajoules for the moment, so don't worry about converting it. And the efficiency of the heater, well, the efficiency of the heater is simply 98% or 0.98, and I'm going to leave everything in fractions there, so not using percentages. So we've got 0.68 megajoules over 0.98, which is 0.693 megajoules. Again, just leaving it in megajoules. So that's the useful energy that's going to the heater from the wind turbine. So the energy supplied by the turbine is exactly that, 0.693 megajoules. So now we can look at the efficiency of the turbine. We're told that that is 37%, but I'm going to use 0.37. Write the equation down again. Efficiency of the turbine is the useful output over the total input. And rearranging that, it's going to be total input, which is going to be the kinetic energy store from the wind. And we're talking about the turbine here. The total input is going to be the useful output divided by the efficiency of the turbine. It's useful to put that lowercase t there just to show it's the turbine and not the heater that I'm dealing with. Substitute those values in, and you get 1.87 megajoules as my kinetic energy store. A very tricky question with two efficiencies involved. Okay, part B, about why heaters have a high efficiency, so 2 marks. And the thing is about heaters is that they work by transferring energy to the surroundings. But you might be thinking, high efficiency means not much energy is transferred to the surroundings. But that's how heaters work. They transfer energy to the surroundings. And therefore, that energy is useful. So once we realize that, we can say that that energy that's transferred to the surroundings isn't wasted, it's useful. So that means the efficiency of the heater is very high. So any that goes through the walls to the outside would be wasted, and then that would make the efficiency smaller. Okay, part C. Pause this because there's a lot of writing there. And it's worth 1 mark, so it's difficult because you have to take in a lot of information for just that 1 mark. So what we've got to write here is that the new material must be a better insulator. And that's where we come from thinking a thinner wall, but the same result thermally. That's how we're going to answer this, by thinking about a better insulator. So I hope you found the walkthrough of some of those exam questions useful. Subscribe to the channel, check out how to improve your understanding of physics and improve your grades. And see you next time on Spiral Physics Education.